6-1 homework time with me, Miss Billman. 6-1 is the first jump into volume that we look at. If you've been in my class for the NASA's Best, we've seen volume of cylinders, which is still fun, but in 6th grade, we don't really talk about those outside of NASA's Best, but it's a good thing that we have had exposure to that vocabulary that goes along with it. So, in these first three, we're looking for surface area and volume. When we're doing surface area, it is different than volume because volume, we're doing length multiplied by width multiplied by height. Surface area, I'm finding the area of each face and I can add up the total and get a sum. I'm going to do the volume first just because it's quick. So 5 multiplied by 6 is 30, multiplied by 3 that is then 90. So I get 90 inches cubed. If I do the surface area, I'm going to do 5 multiplied by 6, 3 multiplied by 6, and 3 multiplied by 5. I'll take the product of each of those, multiply them by 2, and then find the sum. I'm doing that because I know the sides are congruent, so they have 2, and I know each number is going to be used twice in these multiplication problems when finding surface area. So my 30 becomes 60, my 15 becomes 30, and the 18 becomes 36. I add that up, 60 plus 30 plus 36, and I get a total of 126. This is going to be in inches squared. It is different than volume because we are cubing that unit. So if I'm looking at this, every side is labeled 4, 4, and 4 meters. So I can multiply 4 times 4, get 16, multiplied by 4, that's 16 by 4. 6 times 4 is 24, carry the 2, and I get an answer of 64 for the volume, and I multiply 4 times 4 and get 16, multiply that by 6, and get an answer of 96 meters squared for the surface area. Remember, with surface area, when it's a cube, all sides are perfect, I can find the area of one side and multiply it by 6 because they are all the same. That is not the same for rectangular prisms or finding the volume. So let's look at this one. If the first thing I'm going to do is multiply 6 by 10 and I get 60, obviously, and I'm going to multiply that by 2 because I have a front and a back, I get 120. I'm going to do the right side. I multiply 6 by 10 because it has a width of 6 and a height of 10. Multiply that by 2, get 120. Now the top, which will be the top and the bottom because they're congruent, I get 6 times 6, which is 36. Multiply that by 2 and get an answer of 72. Add it all up. 2, 9, 11. Carry the 1. And 3. I get a surface area of 312 yards squared. To find my volume, 6 multiplied by 6 multiplied by 10. 36 times 10 is like saying 36. Add a 0, 360 as my volume, but it's yards cubed. So now let's pick, it's either perimeter, surface area, or volume. If I wanted to find the distance around a shopping mall, that'd be like putting up a fence, so that'd be the perimeter. I can even draw myself a visual picture to see that this would not be volume, and this really wouldn't be area either. If I'm looking for distance around, it's perimeter. The amount of topsoil needed to put in a 2-inch thick layer on top of a square garden, if I'm putting something into it, that's going to be volume, like how much space it takes up. The amount of siding needed for a house, well, it's kind of like wrapping a gift, so that'd be surface area. These are how I remember the difference between the three of them, and I'm sure you can think of your own too. How many inch cubes would it take to fill the aquarium? What is the open surface area of the water? So this is 2 questions. I'm looking for volume, and then I will have to find the area of the top. Volume is length times width times height. So 9 multiplied by 10 multiplied by 15. So 9 times 10, 90 multiplied by 15. I can multiply the 9 by the 15, which is 9 times 5, 45, carry the 4, 9 times 1 plus 4 is 13, and add a 0 because of the 90. So that's my total area is 1,350 inches cubed. Now to find the surface area, that's the total volume. To find the surface area of the top, done. I'm going to multiply 15 times 9. I can go ahead and do that for the top because this is a two-part question. So 15 multiplied by 9. 9 times 5 is 45. Carry the 4. 9 times 1 is 9. Plus 4 is 13. So the top is 135 inches cubed. For good health, a 2-inch long fish requires 48 inches cubed of open surface area. How many fish, about 2 inches long, could be kept in an aquarium with an open surface that is 16 inches by 21 inches? I will tell you, as someone who has had fish in the past and is maybe not the best fish owner, any math I do, I probably will not believe. So 16 multiplied by 21 is 1 times 6, 6, 1. Add these up, 336 inches. Now, that's 336 inches for the open surface. I'm going to divide that by 48 because that's how, for each 2-inch long fish, how much space they require. So I'm going to put 7 down because I know 8 would be too much because it'd be working in 50s. 7 times 8 is 56. Put down a 6, carry the 5. 7 times 4 is 28. Plus 5 is 336. So 7 fish could fit in there because each fish, being 2 inches long, needs that much open area. I probably would have put in like 100 bajillion too many. So the volume of the aquarium for one fish is 384 cubic inches. So they've already done it. They did length times width times height and found that it was 384 cubic inches. The height of the aquarium is 6 inches. Okay. So the base is a square. Oh, so it's going to be 2 of the same numbers. So what is the dimension? So 384 is equal to length times width times 6. I do not know what L and W are. So I divide by 6 to get them alone. 384 divided by 6. 6 goes in there 6 times. Put 36 down. There's a 2. Bring down the 4. 4. So I'm left with 64. So now I've got to ask myself, can you think of 2 numbers that are the same number that multiply together to get 64, knowing they must be the same because the problem gave me the hint that the base is square? So, you know what? I bet it is 8 because 8 times 8 is 64. So the dimensions of that aquarium would be 8 by 8 by 6 to give me an answer of that.